Hello, guys. You're welcome back to the channel. We are going into house wiring fully, but it will not be nice to go into house wiring if you do not understand how energy is generated, how electricity is transferred from the generation station to your residential abode. So I'll have to start from the origin, then I'll break it down to how it's transferred to your home. Then when I go into house wiring fully, when I talk about things like two phases, single lines, double lines, and all that, you will understand what I mean. So let's talk about how energy is generated, and specifically, we are concentrating on the hydroelectric dam. So, how energy is generated from the hydroelectric power system. Okay, so we have a dam. This is a dam here, and this dam here is just a very large barrier or block that is built. Okay, it's a kind of wall or barrier or whatever you call it, a, a wall that is built across a river to trap water and turn the water into a giant battery of energy. That is this wall you see right here now. This wall is built across the river. And when you build this wall across the river, it will seem like to separate the river in two parts. Like one part of the river, the river is flowing to a direction. So since it cannot flow, it will be accumulating. You understand, and create a dam, a dam with high potential energy. So now this dam here has gates. Now these are the gates at the back. Okay, can you see the gates here? Yeah, these are the gates at the back of the dam. Now, if they need water, there's a turbine, a very big turbine that is if it is rotated, if you rotate this turbine, it will generate electricity. So if they want electricity to be generated, this gate will be let open. And when this gate is open, the water will move out at a very great energy. It will move out and it will rotate these blades. Okay, you can see these blades rotating. The water will rotate these blades, and this blade will, because it's connected to a generator, the generator will then generate electricity. Okay, so that is how it works. That's the hydro system work. It's just a barrier that you build. This barrier will now serve as a reservoir for water. It will accumulate enough water with potential energy that if you open the gate, it will flow out. The force, it will flow out and rotate this turbine at a very great speed. And this turbine will rotate and also rotate that is connected to the generator. Will rotate the generator, and this generator will create electrical energy. And the electrical energy is just like, let's say, 11,000 volts to 16,000 volts. Can generate energy as much as low as 16,000 volts. Now there's a system of a voltage drop. You understand the concept of voltage drop? Like as voltage travels along a distance, it will begin to drop due to maybe electrical resistance, cable resistance, heat, and others. So before this 11,000 volts or 16,000 volts we get to the final destination, it may not read up to the 11,000 volts because of voltage drop. So what happened is, big transformers are installed. Transformers can step up voltage. Okay, so this 11,000 volt will be connected to transformers. You can see the transformers here. So these transformers will increase the voltage to 132,000 volts, either 132,000 volts or 330,000 volts, to thousands of voltage before the voltage is transported along electrical conductors. All these power lines you see, they are carrying high voltages either from generation station or maybe distribution section. So these power lines you see, the power lines will now travel far distance. Imagine there are three major dams in Nigeria, and these three major dams, you have the Kenji Dam in Niger State, New Busa, Niger State. We have Jeba, it's also in Niger State, is in Jeba in Niger State. We also have Shiroro. Shiroro is also a dam in Niger State. And the new dam that's adding about 700 megawatt of electricity to the national grid system, the Zungeru Dam, also in Niger State, recently built. It's in Niger State. Now imagine you are generating electricity. You are generating about 11,000 or 16,000 volts, and you are transporting this electricity to Lagos. You can see the distance. So the voltage will drop so much that before it gets to the destination, it may not be up to half of its original voltage. So that's why transformers are used to step up this voltage to 132,000 volts or 330,000 volts. So this voltage will travel along power lines to the destination. That will transported along power lines to other transformers. When they get to your location, the transformer will trap this voltage and step it down until it gets to your transformer. About 11,000 volts will now get into your transformer and bring 240 volts, which is the voltage that is used by our electrical appliances. Okay, so it's the work of the generator, the hydro dam generator, to generate electricity. Then the transformer will pick up this voltage and increase until it get to a place where they need to reduce the voltage until you get to your transformer. The lecture is about house wiring, but I need you to understand how this energy is generated, how this voltage is generated until it gets to your transformer. And this your transformer will now use the 4-line system or 4-cable system to distribute this to your house. You can see electric poles here. Okay, so this is coming from either Kenji Dam, other dams, or coming from thermal power plant. It's coming from the generation station. That's what I want you to understand. So if I go into house wiring fully, how this current or these cables, how they connect to your house, that will be on my next video. You check the next video so you'll be able to understand how these 4 cable connect to your house, the phase system, the line system, and all that. So I just want you to understand the system of power generation, how the hydro power system, how electricity is generated from there, how the turbine is rotated. There's a pipe, there are hoses that are called penstock. These hoses trap water and send it to the turbine. And the gates, there are gates and all that. So I just want you to understand the system of hydroelectric power generation, so that when you go into house wiring fully, you'll be able to understand where this power is coming from. So when I talk about neutral phases, lines, and others, you understand, you will know how it is. So you need to understand the origin of electricity. You don't just go into a field without understanding the origin. That is how it is. It's applied to other professions. You must understand. I will teach you history. So that's what I'm teaching you right now. So that you understand the history of the electric power generation. So we'll go into house wiring. We're going to concentrate on these poles here. I'll tell you what these cables are for, the names of all these lines, and how this line connects to your house. In fact, I will describe it at a stage that it will get to your charger, the charger in your room, your laptop charger. I will explain everything. So how to connect these to your house, that is wired, house wiring. They will now go into house wiring fully. So I believe you already understand how energy is generated. It's just a simple video on how energy is generated. So when I go into house wiring, you will not have any lapses. You will just follow along. Okay, so energy has been generated now. So the next video is about how this current flow to your house, how it flow to your house. Then do house wiring. I'll do an animated video on house wiring and conduit piping and others. Okay, so if you have not clicked on the notification button, do that right now. Click on the subscribe button, because I always give you real-time updates, good lectures. Anything you don't understand, just type it in the comment section and I will respond to you. I may even do a video because of you to explain fully so that you will